Um, consider if you had this region of the square root function. This is the square root graph. Back for your learning pleasure, y equals the square root of x. If this region from 0 to 9 was revolved, if this two-dimensional region then was revolved about the x-axis, so if you took this region and revolved it around the x-axis, then you would get a three-dimensional figure called a solid of revolution. It would look, probably if I took that region out and revolved it around, it would come out, it would be a perfect reflection down here, and then to show this well with perspective, it would probably look something like that, yeah? Now to help you visualize this, I got your handy dandy this. Now I know this isn't the shape that we're revolving, right? But imagine if this shape were taken in two dimensions and it were revolved around this axis of revolution. Then you would get a three-dimensional figure, yeah? Now you can actually get the volume of a sphere that way, and they were able to prove the volume of a sphere formula using calculus and that exact stuff. We'll talk about that in a second. But for now, you're getting a volume of revolution, a two-dimensional figure taken into three dimensions. Now, the question then of the day is, what's the volume of it? How do you find the volume of it? Any idea? All right. Let's go back. How did you find area under a curve? Integrate, all right? Before there was integration, how did you estimate area under a curve? Rectangles, okay? So I could, for example, I could draw maybe a couple different rectangles. Let's say I did 3 rectangles, 3, 6, and 9 here. And we always chose between right and left. We'll use right here. So if I used a right rectangle here, then it would look like that. Now, what about, this isn't quite as awesome, but what if I revolve a rectangle? Say if I took this and revolved it, then what kind of figure would be, if you look at that in motion, what kind of figure is that? What? Not a circle. It's a cylinder, yeah. A cylinder. If you took this and revolved it, then it would look like that. Now, surely that would be too much, yeah? Just like the rectangle is too much, that cylinder is too much for the volume. So we would have to deal with that. We could do a second rectangle here and revolve it. And when we do that, that would also be a cylinder, like that. And we could do a third here. Upper, revolve it, and we get a third there. Now that would be a good estimate of the volume, but it wouldn't be perfect. How could I get a better estimate of the volume? Do what? Make them smaller and thinner. Yeah, more of them and smaller and thinner. So instead I could do mini cylinders, and I would have less error. All right. So, what does the next part of my notes say? That's not good. So what the question is, how to find the volume. So the idea is some mini cylinders. Now, what I would like you then to do is take that calculus idea at the heart of that you know, that you sum infinitely many infinitely thin with an interval. And summing, I'll give you 3 minutes to find the volume of that figure. You may use a calculator if you like. Go. Although you'll find it's not that hard. Give me the number for that. What's the volume of that figure perfectly? Talk it over with your mathematician. you'll find that if you're doing this well, the calculator, you'll laugh at even using it. Do that much. Let me know when you have your answer. Don't you dare look it up, you weasels. Figure it out yourself. Tell me your answer. Volume of the cylinder, that's a great start. Many cylinders, infinitely many cylinders. What is the volume of a cylinder? Oh, come on. No, that's a sphere. Come on, people. Pi r squared for the area of the base times the height. It's a prism. Okay, two bases, same cross section. It's a prism. Area of the base is pi r squared. Okay. Now you need to figure out what happens as you take infinitely many. What's the r? What's the h? What's the calculus? Are you ready? No? You got it? That's true. What about the height? Did you just pull it out? Okay, so you're right there. There's how many sections? Yes. You got it? You are on the right track, but why is it fast? Why is it slow? There you go. So then you would have, yep. Okay, so let's talk. There are a handful of people that nailed it. Okay, so let me give you a little more prodding and make you say it on your own. Just like in rectangles, there is a Riemann sum at work. It's the sum of many cylinders, and as you take infinitely many, n stands for the number you make. As you take infinitely many, you get better and better fit. Okay, better and better volume, less and less error, right? Less and less overage. You with me? Okay, so in order to pull this off, we know that this infinite sum is what an integral does. An infinite. We have to then account for everything else. Well, the pi is a constant, so it's no big deal. But the radius, well, here's a radius, and here's a radius, and here's a radius, and here's a radius. And here's a radius. Well, that stinks because the radius is changing. It's varying. What is the radius? Is it x or y? If it's varying, it's got to be a variable. Is it x or y? It's y. Okay. This is a this is a y of 1, a y of 2, a y of 4. It's never 4 never, but you don't understand. You with me? Okay. So it feels like the y is the radius. I might have to play with that. Now the height is the hard part. Here's the height each time, yeah? And that's a change. I know it's like an x measure, but it's more like it's not actually the x at this point. It's a change between two x's. So it's like a delta x, yeah? But as you get infinitely small, that height gets smaller and smaller and smaller. As we do more, that height gets super thin. And so instead of a delta x, it starts to approach a dx. Now that means then that I can't let this y thing go. It's an x integral. It's got to be made in x terms. So I'm going to put the pi out front. That's not an issue. But I need to replace y with its x equivalent for this problem, which is root x. And now because they're x, the limits of integration have to be x-ish. So are we talking 0 to 9 or 0 to 3? 0 to 9. All right, then. As I said, if you set this up correctly, then the calculator should be a non-issue. What's the antiderivative of x? 1/2 x squared, or I guess I'll leave the pi out there. Pi over 2x squared from 0 to 9. So the area, or the volume rather, is 81 pi over 2. You follow? Okay. Well then, we will play around with this. But let's first get the big idea of the day down here. These questions were meant to kind of guide you, but didn't I have another slide there? Isn't there one with a couple of big boxes in there or something? Yeah. Where is that? Oh, there it is. Okay. Okay. Now then, a basic analogy of calculus, then you would say that area by rectangles is to area under a curve is to volume by cylinders is to a volume of revolution. It's the same idea of you can take a finite to estimate the infinite, and doing so gives you, if you do it infinitely many, infinitely thin, becomes an integral problem. But there's this finite as an estimation. This idea comes from summing many rectangles. So then, say again, revolution or cylinders. Okay, sorry, my handwriting's terrible. A solid of revolution then. If I were to talk about any curve, let's just call it f of x, over a region, whatever, let's just say from A to B. If I were to revolve this around the x-axis, then I get a volume of revolution. And I can get the volume of that by finding the sum of all these tiny disks. Now these, I know they're cylinders, but when they're infinitely thin, we typically call them disks. This is called the disk method. Actually, two methods to finding volume. We'll do the other one later. But these summing millimini disks, imagine like if you had a roll of quarters just added. No matter how I tweak the quarters, the volume would still be the same, whether it was a straight cylinder or if I kind of push the middle. It would still be the same volume, and it would still be the sum of many of those quarters, all right? Now, the idea is that the volume is usually the pi's out front, but the radius squared, remember the idea is pi r squared h. The radius is the function of the y, but we're going to put it in x terms. And it's pi r squared, so that's squared. The height here is infinitesimally thin, and so the height is dx. And because it's x as a variable, the limits in integration have to be x values. So they would go left to right of the region. A to B represents the left edge and the right edge. So that's the method of finding volume by revolution when you use x. You with me so far? All right. If you then tried one maybe together and then let's go a couple and see what this is like. All right. So imagine if we found the volume of this. I know some of you are not artistically inclined. Do your best. I require a picture. Those of you who aren't artistically inclined, well, you're going to love this. All right. So x squared. And the x-axis from -2 to 2 would be this kind of region there, yeah? And I mean those little triangular regions on the outside. You follow? If that's revolved around the x-axis, then the volume of revolution, now, for those of you who are not artistically inclined, the best way to draw this revolution is to draw a reflection like that, and then connect the far points by arcs, like that. So it's going to look kind of like that, a bow tie or a TIE fighter kind of thing, if you're at Star Wars. All right, now then, the volume of that bad boy. The volume is pi. It's the sum of many of these disks. I'm adding lots of these little disks or cylinders. So it's pi r squared h. What's the r? X squared. Yeah, the radius is always changing, but it's always tied just to the curve. So it's x squared squared. And yeah, both squares need to be there. Okay. What's the height? dx. And what are the limits of integration? -2 to 2. Wonderful. Okay. What's the antiderivative of x to the 4th? X to the 5th over 5. So if we evaluate it at 2, what's 2 to the 5th? 32 over 5. Minus what's -2 to the 5th? -32 over 5. Then 32 minus -32 is 64 pi over 5. Write yourself a note here. Volume should always be positive. Just like area. If you get a negative, you messed up. All right? Try the next one. Now, the next one's kind of funky, but I want to do less of me and more of you, so work on it together. Make sure you get a decent-sized picture to do this well. Don't give me some little baby thumbnail-sized So you got two different regions. Make sure you identify the region correctly. Actually, in order for you to not waste your time, let's make sure you understand. Those are the two graphs, right? But they also say those and the x-axis. So I'm not talking this region. That is not enclosed by the graphs and the x-axis. What's the region that's enclosed by the graphs and the x-axis? It's this one. This is the volume of revolution. Okay. Now it helps to have the district here shown. Actually, should we just do this together, or do you want to do it in your? Okay. So, what's harder about this? It's two. Okay. If we were doing the area, it would require two integrals. Well, it will definitely require two integrals for volume as well. Why does it require two? There's two graphs. There's two different radii associated with this. One is the parabola, but once you get over here, then the radii are the line. You can't do that in one integral. It's got to be done in two. All right. Can anybody just tell me, guess and check wise, what's the intersection point? I understand when you say zero, I assume you're starting with the left-hand endpoint. I agree, but what's the intersection point? All right, we'll find it. Jesus. What? 2, positive 2 or negative 2? X is? Negative 3 and 2. Now the one of interest to us is it negative 3 or 2? 2. This one's the positive one. 2. And the y, I guess I could find it's 4, but I don't think I'll need it. All right. So tell me, what's my first integral? 0 to 2, pi out front, the radius squared. Now the radius is constantly changing. Here's a radius, here's a radius, here's a radius. But for a while, the radius is directly tied to the parabola. So instead of radius squared, we're going to use x squared. Then we hand off to a new integral. Pi from where to where? 2 to pi 6. What's the y-intercept of the line? 6. How does it slope? Down 1 over 1. So 1 would have to hit at 6. You know, starting at 6, it's going down 1 over 1. If you need to find the intersection, then I guess this homework's going to take you for free camp. Come on, people. So 0 to 6, or 2 to 6, right? All right. What's the radius? Negative x plus 6, and it needs to be squared. All right. Now here's where we're starting to go conceptual, and it's going to bank on you having great integration skills, or at least rapidly solidifying integration skills. The first one's not an issue. We already did that once. So pi times x to the 5th over 5, that's not a big deal. We'll deal with that in a minute. But this guy, can I integrate that the way it is? I guess you could try and use sub. You could use sub it, but I wouldn't. So what's a better way to integrate that? Factor it out. What is that factored out or multiplied out, FOILed out? X squared. It'll be a 36. Please don't just square those two. That'll make me mad. 12x minus or negative or positive 12x? Negative 12x plus 36. Okay. So what is that integrated? 1/3 x cubed minus 6x squared plus 36x from 2 to 6. Cool. All right, here we go. Pi. You could have a grand pi out all the way up front. I'm putting pi in front of each, but you could put a pi up front of the whole thing, whatever you want. What do we get in the first evaluation? 32 over 5. All right, cool. Plus pi. This one's going to require fundamental theorem 2 evaluations. What's 6 cubed? 216. 216 over 3 minus 6 cubed again, or 6 times 6 squared, so 216. Plus 36 times 6, 216, that's delightful. Minus 2 cubed over 3, 8 thirds, 2 squared times negative 6, negative 24, 36 times 2. 72. Cool. All right. 32 applied to 5. I'm going to still keep that over there. But pi. So these guys go away, yeah? What is 216 thirds? 72. So that's actually also great. 72. This is 72, and we're subtracting 72. So those guys are going to be goners. Very cool? All right. So that's then negative 8 thirds plus 24. Negative 8 thirds plus 24. Let's combine. All right, so all together we're going to have a big old pi term. What's the common denominator? Between all three of those. Let's go with all three now. 15, okay. So 32, what did you need to multiply it by? 3, so 96. The 8, would you have to multiply it by? 5, so it's negative 40. And the 24, would you have to multiply by 15? What's 24 times 15? 24 times 10 is 240. Half of that is 120. So 240, 120 is 360. Okay, so 360 plus 96. Actually, let's go. What's 320 plus 96? 320 plus 96 is 416. I heard. Sorry, somebody said it and I didn't listen. Pre-algebra. Is 416 divisible by 3? What's the rule for divisibility by 3? Just wonder if you still know. Now, you'll notice that I haven't been putting units on this. Units cubed or whatever. And there are some college professors that are very picky about it. Now, this is one of the few times that I'm going to bend good math rules to AP strategy. I'm not a big, I just say do good math. But on the AP test, they don't grade for units, and that goes for area and volume. Now, that said, if you leave them off, you lose nothing. But if you put units on and you have them wrong, they do take off. So putting on units can gain you nothing, but can lose you points. So you'll find that I just generally leave units off on area and volume. All right? Okay. Part 2 of the lesson. All right. Now, it's possible that instead of revolving around the x-axis, you can revolve a region around the y-axis. Now, same graph, but this is a little different region. It says, yeah, take the square root graph, but this time use the y-axis and y equal 3. So I'm talking about, oops, this region here. Now, not the lower region like we used earlier, okay? Different region. Now we're revolving it around the y-axis. Now, if you were to show the reflection of that, and then a little perspective, it would look a bit like a funnel, yeah? Now, we could still do X slices, but it wouldn't be cylinders anymore. That's actually a shell method. Now, if it's, would you write yourself around a note? If it's around the x-axis, use X. But if it's around the y-axis, use Y. Now, what do I mean by use Y? What does that mean? Well, first of all, it means that you'll use a Y in the integral. But second, your rectangles, instead of being, when we do X rectangles, we do them this way, yeah? And it's dx thick. But when we do Y rectangles, we do them, oops, this way, and it's dy high. So when I say use Y, we're actually going to be using rectangles like this and revolving them. Now, here then, the radius is actually going to be an x measure here. The radius is 1 unit, or 2 units, or 4 units, or 9 units. Each time I identify a radius, that's really an x value. Now you probably say, maybe you just say it's going to be a y. Well, what's the height? The height is a movement up and down. That's a delta y. And so this height is going to be dy. So when I say the radius is x, you must put it in y terms. Because the integral is going to be a y function. So here's the deal. The volume is still going to be the sum of many cylinders, like before. But in this case, instead of the height being dx, it's dy. Now, the radius is just really whatever x is, but what is x? If y equals x, the square root of x, then x is y squared. Last but not least, be careful with the limits. Are they going to be x values or y values? They have to be y values. So should it be 0 to 9? No, it should be 0 to 3. All right, so if you were to integrate that, what is the antiderivative of y to the 4th? Once again, y to the 5th, so pi y to the 5th over 5 from 0 to 3. That one's a little uglier. What is 3 to the 5th? Anybody know? 243. Sometimes you have good arithmetic skills. 243 pi over 5. Okay? Now, if you get a volume of revolution around the y-axis, then the volume is pi r squared h, but the h is dy. And instead of being a function of x, the radius will be a function of y, or the function in y terms. And these will be y values, y low to y high. All right? Try that next one on your own or with your math amigo. So we really need to talk about. In the interest of time, if you want to use your calculator, you may. Actually, it's not too bad to integrate, is it? How are we doing? Is y, are the limits negative 2 to 2 or 0 to 4? 0. 4, so what are we getting here? Maybe 16 minus 8 minus 0. What'd you get? You get 8 pi for volume. Okay. So, let's just anticipate this case. Imagine if you had this graph. Oh, the graphs, actually there's 2 regions. It says the region enclosed by these in the y-axis, but it's not, does it say, oh, it says first quadrant region. So it's this region here revolved around the y-axis, yeah? So I would not include this part of the sketch because it's going to confuse me. So when I revolve that, what would have to happen when I took this and revolved it around the y-axis? What kind of calculus would I have to do? Talk to me, people. How many regions? 2. Yeah, you'd have to do 2 integrals. Okay, so it's a little like that previous one because you have 2 different boundaries. You would have to do 2 integrals. What I really would like to get to is the last one. This is more and more common on the AP exam. They're doing these more conceptual type of questions. I want to think about this. So if I wanted the volume of this vase, you could try and find at different heights what the radius is. So for example, they said at 0 this is 2 units in radius. And at 2...
Good morning, Cavalier Jaguars. Please rise to the Pledge of Allegiance. Please begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
All students, the honor roll list for fall semester has been posted by the front office. Please double check the list to make sure it's correct.
Please report during 7th hour today to your 6th period class. After attendance is taken, 7th graders will report to the auditorium at 2:10 when you are called.
Shoot, I didn't do this very well.
Today's information meeting for the CU Succeed course for the philosophy and ethics will be held in room E100, not in the auditorium.
I didn't do that.
Colorado Mountain College is offering an information night for 3 arts.
Imagine if that went to the top.
January
It's supposed to
31st
work.
at 7 p.m. Learn more about the admissions process, scholarships, student support services, residential life, and more. There will be prizes including a CNC student designed snowboard. Chocolate has the details.
Musical costumes crew. We will meet on Wednesday and Thursday this week at 2:45 in the drama room. Please let Ms. Hannah know if you can't be there.
A few years ago, students requested a space where they could eat and study in silence, so we created the Library Commons. If you use the Commons, please respect the wishes of your peers. This is the only space in the school dedicated for silent study.
Hey there, Jack Delicious students. Are you pumped for the upcoming holidays? Are you upset that you aren't getting any Valentine's cards from your crush? Cope with that by sending us pics. We need pictures of your Halloween costumes, Christmas celebrations, and whatever holidays you celebrated since August 2018. Send in those saucy pictures of your New Year's kiss. Make it PG though. Send them in to yourbuzzcast.jags@gmail.com. Have a great day.
Do not forget to get out and support your athletes this afternoon. Swing by Boba Zone at Kipling and Value next to the Dairy Queen and get a great drink to go with your savory dinner from Sunny Coast Tiger.
I like both.
At both places, and a portion of the proceeds will go to support your girls' Swift team and boys' basketball.
I'll finish this tomorrow.
Senior high students. All high school athletes who are interested in track and field this spring come to the library at 2:15 p.m. Listen for the announcements to be excused from your 7th hour class. If you can't attend, see Coach Bell or Coach Porter after school.
Junior high students, Dinosaur Ridge Summer Camp registration is open for 7th and 8th graders for June 10th
Any questions on last night
Learn
you'd
about
like me
fossils,
to?
geology, earth science, local plants, and animals.
One,
It's usually the Southside Council.
21, 3,
Boys basketball is on Stanley Lake at home tonight at 7 p.m.
4,
Let's hack the jungle. Use alligator rifle.
22,
And if you live up
2,
north, the girls play at Stanley Lake
2
tonight as
and
well.
20,
That's all your announcements. Have a great day.
19. Any others? 5? Answer to 25 is not posted. Okay, got you. It's a replacement. I'm with you. Okay, I'll do those at lunch and I'll be posted at lunch. So if you can get this to me by the end of the day, that would be great. I will say this, I understand you don't have a 7th hour, but as this happens, when I only am able to post answers, if what I write doesn't make sense to you, then it's kind of on you to say, I saw what you put online, but I still don't get what you're doing. That's just going to be necessary. Okay? You go to 6th and 7th hour, I believe. Oh, are you recording those? No, I don't. I think there's I don't know if I know it's either 6 or 7. Hey, hi. 72? Yeah.
No, I'm gonna be here. This is my one day off.
Oh, I got you. Where do you work?
I work at Pie Shop.
Oh, you work over at the one in Grace Street?
Yeah.
Oh, Granny Smith?
Scott's, yeah.
Granny Scott's, that's what it is. I know that place. So good. You just got a cherry almond last week. 72, you said. There's 72's problems there, and you'll be here for I'll finish this tomorrow.